Welcome. The next topic that we'll be discussing is called as classification of air conditioning systems. Now, this is a very important topic in HVACR or our course because without learning about these kind of systems or air conditioning systems, we'll never be able to install or work or design on an air distribution system. So because of it, we need to first of all understand what are the different types of machines used in air conditioning industry or in HVAC and R. So basically, air conditioning system or air conditioning machineries employ a common system of a refrigeration cycle for cooling systems and a heating cycle for heating systems. Anyways, whenever we install an air distribution system, air conditioning system or air distribution system, we need to have a fan. A fan is the equipment which will be controlling the passage of air throughout our machineries. So in every air conditioning machineries, the components will be somewhat similar. You will always have some kind of a technology to clean the air or filter the air. You will always have some kind of a technology to either cool the air or heat up the air. And to pass the air, you will always require a fan or a blower system. All these combined with different kind of specifications, different kind of sizes, shapes, capacities, all constitute this topic, which is classification of air conditioning systems. Now we'll look more into detail of our classification of air conditioning systems or this topic. The classification of air distribution systems can be represented in this diagram. Air conditioning systems or air distribution or air conditioning systems are classified into non-centralized and centralized systems. The basic difference between a non-centralized system and centralized system is that a centralized system will always have a centralized control over the entire area or spaces that the system is controlling or conditioning. That means you will always have a centralized control panel on which you can control every space or the temperature or the humidity level in every space with a singular remote control, or maybe you have a control panel. Whatever it is you require, you can do it. In the case of a non-centralized system, however, you do not have this centralized control. A non-centralized system, just like a small high volt split AC, can only condition a small area or a small room without having like much provision of controlling the other room on the other side of the building or something. So anyways, a centralized system will always have a centralized control over a bigger area. A non-centralized system will not have this kind of a control. There are other differences that we will discuss later on when we actually learn about all these different types of machineries or different types of air conditioning systems. So first of all, for right now, I'll just explain to you what are different types of non-centralized systems. Non-centralized systems are classified basically into two, a window AC and a split AC. A window AC is the most simplest idea of an air conditioning system. It will be normally installed on a wall, or it's a wall mounted machinery, and it will be installed on a wall which is separating our conditioned area and the atmosphere. We will have to make a window on the wall or make a small puncture or the puncture on the wall, and we will have to install the machine on that puncture. So they will be working between our room air and the atmospheric air, just like a small box. So that is the working of window AC. We'll explain that. I'll explain that later onwards. Then you have a split AC. In the case of a split AC, the entire box of the window AC will be split in half. You will have two sections. One section is an indoor unit. The other section will be outdoor unit. As the name suggests, the indoor unit will be installed inside the room and the outdoor unit will be installed outside the room or on the atmosphere. So you have a provision of moving the indoor unit inside the room itself. So that is how we classify non-centralized systems, a window AC and a split AC. There are four types of split AC that we will have to learn: a high volt split AC, cassette AC, concealed AC and a tower AC. I'll explain that later onwards. Then we'll move into a centralized system. Centralized system is much more complicated, it's much more bigger system probably compared to non-centralized systems. So a centralized system can be classified into basically 5 systems. First one is a ductable split AC. It's one of the very common and very simple centralized system. It will have a main unit of an indoor, it will have a main outdoor unit. The indoor will have its own controls or thermostats through which we can control the entire spaces on which we have provided something called as a ducting, which is used for air distribution. Similarly, we have something called as a ductable package AC, which is a floor mount AC. I'll explain that later onwards. Then you have rooftop unit, VRF, VRV. VRF is a short form for variable refrigerant flow, whereas VRV is variable refrigerant volume. Ideally, both of them are very same and very similar in concept. Only that the names actually vary, but it's not much of a concern. Anyway, this is actually a very similar concept, or a very simple and same concept. Chiller, I'll explain later onwards. Chillers are much more bigger machineries that use normally a secondary refrigerant, which I have explained in the case of refrigerants, to cool down the entire building. So you'll have primary refrigerants, secondary refrigerants. Using secondary, you can cool down the building. So I'll explain all of these in detail. So we move into, first of all, non-centralized systems. Now let's learn about non-centralized air conditioning systems. In the case of non-centralized air conditioning systems, the first one, or the simplest one that we have to learn, is called as a window AC. I told you about this. A window AC will be always installed on the wall, which is separating our air conditioning area and the atmospheric area with a puncture or a window. In that window, enclosing that window, we'll be installing our machinery. So suppose this is the wall which is separating our room air and the atmospheric air. So this will be our room, and let this be the atmosphere. So one part of our machine will be inside the room, where the other part will be always outside the room or on the atmosphere. Now in this machinery, you can see a lot of components. I'll explain each and every one. So in this section, you can see an air filter, which will be inside the indoor side of the machinery, that is used to clean the air whenever the air is going inside your machine. Then after the air filter, immediately after the air filter, you can find evaporator coil. On that, you will be finding evaporator coil fin source. The coil will be, as you know, will be made out of copper, and we will be having aluminum fins over the copper coils to increase the heat transfer area, so that we will have a much better cooling. And then you have, after that, you will find your fan, and that fan is here, which is basically the evaporator fan, and it is actually a centrifugal blower fan. The working of a centrifugal blower fan is that when a centrifugal blower fan rotates, air will be always sucked in through the center and will be discharged to the radial direction, as in the figure. So the air, when this is rotating, you will have suction through this side and this side. Since you have a closed wall here, there won't be any suction happening from the back side of the fan, only through the front. So the room air will be always sucked in this direction. When it passes through here, you will have grills here. Because of the grills, the air will be cleaned by the air filter. When it passes through the evaporator coil, it will be cooled, dehumidified, and that goes into your fan suction. And what the fan does is, it will discharge all the air into the radial direction or to the sides. So what happens is, you will have inside vanes which direct the flow of air coming from the fan back into the room. So what happens is, if this is the room, the air goes in like this, gets filtered, cooled down, dehumidified, goes out like this. So you have an airflow happening like this. Always the room air will be circled throughout this machinery, will be filtered, cooled, dehumidified, and will be supplied back. In this section, you can find a small fresh air vent here, which will be having a small lever which will be connected to the indoor side. If I want, I can pull that lever, open this small hole. So when this fan is rotating, you will have suction from here also. That will indicate that I will have a provision to adjust the oxygen level if I want, because after some like a continuous period of time, the people sitting inside the room may feel suffocated, because they will be absorbing all the oxygen, will be giving out all the carbon dioxide. If they want fresh air to enter the room, they can pull the lever and allow fresh air to go inside. This is not in every machinery, but in some models we can actually see it. Then after that, you will find something called as a drain pan underneath your evaporator coil. The drain pan is used here to collect all the dehumidified water that is dripping down from your evaporator coils and fins. It will be collected in the drain pan. It goes through a PVC pipe like here, which is called as a drain pipe. It comes out with the U-trap. The U-trap is provided so that the smell won't come here, and also some insects or something like that will not actually go into your machine indoor. So it will actually come here, goes through your drain pipe, U-trap, goes out into the nearest drain point. So all that we have, I have explained what's happening inside your indoor side of your window AC. So in the inside of the window AC, these things will be happening. One thing that will be happening is air goes inside, it will be filled, it will be clean, dehumidified, cooled, where it rejects heat into the evaporator coil. Inside you can see the evaporator coil. So inside the evaporator coil, the refrigerant will be evaporated, where it will be coming out as a refrigerant vapor. The refrigerant vapor will be sucked inside the compressor, it will be discharging with high pressure, high temperature, goes into the condenser coil. This is what we have to understand. The condenser coil, the refrigerant vapor or high temperature, high pressure vapor in the condenser coil have to be cooled down to a liquid state. To cool this down, I can use another fan here, which is the condenser fan, which is basically an axial fan. The axial fan sucks in atmospheric air and it will be discharged over the condenser coil, or it will be sucking through the condenser coil, whatever it is. Because of the rotation of this axial fan or the condenser fan, the refrigerant or hot refrigerant inside the condenser copper coil will be cooled down into a liquid state, which goes through your expansion valve, passes through it, gets suddenly expanded, reduces its pressure, reduces thereby its temperature, goes back into your evaporator coil, thereby repeating the entire process of vapor compression refrigeration cycle. Now this machine is an efficient machinery for doing our normal small scale air conditioning applications, because it's a very small compact unit. You can install it easily on a wall, and after you install it, giving electricity to it or energy to it, it works pretty well. But the main disadvantage of a window AC is that it has a size constraint. If you want to install a 10-ton machinery, a window AC construction is never going to be practical, because the hole required for that on your wall will be too big. That is the main disadvantage of going for a window AC, because you can't go for a higher capacity machinery. Normally window ACs are available up to 1.5 tons. Because of it, you don't use window ACs more than that specification. Right. Now the technical specification of window ACs is as given in the figure. You have this much specifications for every window ACs available in the market right now. Now, another disadvantage of going for a window AC is that you can never install a window AC on a wall which is separating our room and another room. Because if you install that on that wall, what happens is when our room gets cooled down, the other room onto which the outdoor side of the machine is actually exposed to, that room will get heated up. So you can only install such a machine on a wall which is separating our room and the atmosphere. Never you can install it on any other walls. So because of it, the application of window AC is very limited to some rooms only. So because of that reason only, we have to go for other kind of machineries or other kind of air conditioning systems. The disadvantage of putting a window AC on only a wall which is separating our area and the atmosphere made us go for or design another system which will enable us to put the indoor side or put the air conditioning machine inside in any wall or any space that we can, and put the outdoor on the outside or in the atmosphere in a preferred or a comfortable location. So because of it, what we did is the window AC is split into two sections. One is called as indoor unit, the other one is called as outdoor unit. The indoor unit and outdoor unit is connected by a set of copper coils or copper tubes. Through the tube you will have the transfer of refrigerants. So what happens is the indoor unit we can put anywhere inside the building or anywhere inside the room, provided there will be a constraint on the length of piping in between these two. The outdoor unit, as our requirement or as per our comfort, we can put on the outside, providing a proper stand for it, where you will have the other systems. Now, if I want to go for a cooling system, you obviously will have to use the evaporator coil inside the room, because the evaporator coil is the cold component in our ECR cycle.